Assalamualaikum warahmatullahi wabarakatuh and good morning everyone.
Good morning, Miss.
Okay, morning.
Salam Miss.
Saya harap hari ni kita punya line okay. Okay, so kita akan buat tutorial on chapter 7, the very first tutorial. Okay, as for the first tutorial for this topic, kita akan cover for nomenclature. Okay, nomenclature semalam dalam lecture saya tak ada buat, tapi dia sama sahaja macam dekat dalam kita punya alkene. Cuma halogen now will become the prefix, the substituent yang berada di depan, bukan sebagai suffix yang family. Okay, the learning outcome for this non-face-to-face questions, okay, untuk draw structures and classify primary, secondary and tertiary alkali halide. So each and every time kita jumpa haloalkene dalam this tutorial, kita akan try to classify juga. Walaupun diminta nama tapi nak minta classify and etc. Okay, and then we need to name them according to IUPAC nomenclature, simply the prefix, parent dan juga suffix. Dengarkan suara saya?
Dengar Miss.
Alright, so kita start what and the first one here. So the first compound given, okay, dia cakap 2-bromo 2-methyl butane. So how are we going to start doing this structure? Macam mana kita nak start? 2-bromo 2-methyl butane. How do we start doing this structure?
By carbon.
Carbon. Thank you. 4 carbon comes from the butane here. This one belongs to 4 carbons. Okay, so kita akan ada 1, 2, 3, 4. So this is the butane. And then at carbon number 2, let's say we start the numbering from the left. We have carbon number 2. We got 2 substituents attached to it. One is bromo. Another one is methyl. Okay, jadi sekarang tolong beritahu saya, what is the class of haloalkene for this 2-bromo 2-methyl butane? Apa kelas dia? Macam mana kita nak tengok dia punya class of haloalkene?
Depends on how much carbon attached to the carbon.
Yes, depends on how many carbons directly attached to the carbon bearing the halogen. Okay, kita ada this carbon bearing the bromine. Let's look at how many carbon attached to it. 1, 2, and 3, is it? So what is the class of alkyl halide here? Apa kelas dia? Yes, tertiary alkyl halide. Okay, good. Ataupun tertiary haloalkane lah. Okay, tertiary alkyl halide. Jangan biar tertiary je, kita kena beritahu dia benda apa. Okay, next one. We have this 3-iodomethyl, 3-phenyl heptane. Okay, so kalau awak nampak sekarang ni, dia ada substituents. But at the same time, dalam kurungan. Apa maksud dalam kurungan ni? Selalunya kan kita tak letak kurungan, kita just hyphen, kita ada comma. Kenapa tiba-tiba ada kurungan dekat substituents?
Maksudnya macam ada substituent dalam substituent.
Betul, ada substituent dalam substituents. Okay, so sekarang jom kita buat benda ni. Kita start dengan apa dulu? Our longest carbon chain consists of how many carbons?
7.
7 carbons. Jadi kita ada 1, saya buat bawah sikit. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Lepas tu, both substituents is located at carbon number 3. So let's say this is your carbon number 3. Kita nak letak 2 substituent. Okay. Macam mana kita nak lukis? Kita ada first phenyl dulu. Phenyl ni siapa substituent awak? How does phenyl looks like? Macam mana phenyl punya rupa?
Benzene ring.
Benzene ring. Dia benzene ring as substituent ada 2 case. Yang ni yang mana satu? Got extra CH2 or not?
No.
No extra CH2 . Okay, jadi kita tarik dia. Terus kita ada benzene ring kat sini. 1, 2, 3, 4. So, benzene ring. Betul tak saya lukis benzene ring ni? Ke tak lengkap lagi?
Kena ada dalam situ.
Okay, dalam dia ada apa? Satu je dah beban.
3.
3. So kita kena tahu this benzene ring is an aromatic ring. Let's recall again, we have 4 criteria to obey the aromaticity. One of them is completely conjugated. Okay, so bila ada carbon-carbon double bond keliling dia, dia completely conjugated lah. Okay, this is your phenyl, settle. What about the other one? We have substituents on top of the substituent. So siapa yang patut kita lukis dulu?
Metal.
Metal. Metal consists of 1 carbon. Okay, settle. Lepas tu dekat dalam metal kita ada iodo, right? Okay, kalau ada iodo, kita terus tulis I ke kita kena tarik lagi bond?
Tarik lagi bond.
Yes, tarik lagi satu kat sini. So kita ada I. Sebab kita punya carbon satu, the carbon number 1 kat sini. So carbon that bearing the I. We're not talking about the haloalkane. The electrophilic site taking place dekat carbon yang bearing the I. Okay, good. So what is the class of this carbon bearing the I? Ada berapa alkyl group attached to it? This one, ada berapa alkyl group attached to it? Ada berapa?
1.
Satu ni, yang besar ni semua dia punya. Okay, so dia adalah primary alkyl halide. Okay. Halide. Next one. Kita ada 1 chloro, 2 isopropyl cyclohexene. So who's going to be your parents and also the suffix?
Cyclohexane.
Cyclohexane contain how many carbons?
6.
6 carbon. Okay, so kita ada 1, 2, 3, 4, 5, 6. Okay, so this is your cyclohexane. So we have 1 chloro and 2 isopropyl. So you can start from everywhere. Atas boleh, bawah boleh, kanan boleh, kiri boleh. Let's say kita start kat sini. This is carbon number 1. So our carbon number 2 here. Okay, awak boleh letak 1 chloro maksudnya ada chlorine. 2 isopropyl. So this 2 isopropyl is a branch alkyl group. How do you draw the isopropyl? Consists of how many carbons altogether? The isopropyl.
3.
3. Okay, so kita
3.
tahu macam nak lukis dia. Sorry. Kita ada macam ni. Iso kena sama dia punya environment CH3 hujung. Lepas tu total up 3 yang kita jumpa dari parent chain. So this is your isopropyl. So what is the class of carbon bearing the chlorine in here? Secondary, because they are attached to 2 alkyl group. Okay, so this is a secondary alkyl halide. Okay. Habis untuk the first question, proceed to the next question. Now, you need to name the compound according to IUPAC given to you the structural formula. Okay, so now look at this structure A. We have how many carbons that make up the longest carbon chain?
5.
5. So the 5, macam mana kita nak start dia? Kita nak start daripada kiri ke kanan the numbering?
Kanan.
Kanan. So 1, 2, 3, 4 and 5. So we must have metaprop-butane. So kita ada pentane. So we got pentane here. Okay, pentane. Kenapa kita pilih kanan? Sebab kita jumpa banyak substituents and the lowest combinations of number starting from the right. Kalau dari kiri, kita akan start daripada sini numbering dia. 3, 4, 5. So priority dia sama je lah macam alkane. Well, now we have 3 substituents. Okay, one of them is fluoro. This starts with letter F. And then another 2, we got M. Between M dengan F, who comes first in terms of alphabetical order?
F.
F. So kita kena namakan F dulu. So F tu nama dia apa? Together with the locations? 1,
Fluoro.
1 fluoro. Fluorine, fluoro. Okay, lepas tu kita ada carbon number 2 and 3 hold the same substituents, then we need to put prefix before them. Jadi kita kena mention both locations 2, 3. Before we mention the methyl, kita kena letak prefix apa dalam ni?
Dimethyl.
Yes, dimethyl, and make sure there's no spacing between them. Okay, so siaplah kita punya naming for the first structure. 1-fluoro, 2,3-dimethyl, pentane. Okay. Lagi kita ada another structure here. Who's going to be the parent chain? Siapa parent chain kita?
Cyclohexane.
Cyclohexane. So nama dia cyclohexane. Okay, when you have cyclic structure, kalau satu substituent tak perlu letak numbering. But now, dan dia tak ada important functional group lah kalau dalam cyclohexane tu. Kalau cyclohexane kena letak numbering lah once you ada substituents lain. Now, kita akan ikut dua benda, tengok dulu sama ada dia punya lowest combination or not. Kalau sama, baru tengok alphabet. Okay, for this case, kita boleh buat it's either starting from here 1, 2, 3 or 1, 2, 3. Okay, sekarang ni awak tengok. Kalau kita guna yang kat luar, nombor yang kat luar saya letak tu, kita akan ada C, lepas tu kita jumpa M. Kalau kita start daripada yang dalam, kita jumpa M baru C. Kalau ikut alphabetical order, kita nak ambil M dulu ke C?
C.
C. So the numbering akan ikut yang urutan yang luar. So nama dia apa dia dalam ni? 1.
1-fluoro, 2 ethyl methyl.
Ethyl. Lepas tu, ethyl dengan methyl sekali ke?
Oh tak.
Ethyl lain, methyl lain. Kalau dia nak sama, kena letak di lah. Tapi dia tak boleh lah sebab dia case lain. Last sekali kita ada 3
3-methyl.
3 methyl. Sekejap. Okay. 3 methyl cyclohexane. So it's quite straightforward lah untuk nomenclature for haloalkene. Alright, so kita akan proceed terus dengan soalan face to face. Okay, this question for face to face, the learning outcome is to describe haloalkenes as compound that contain polar bond. Okay, semalam kita discuss tentang beza antara alkene dengan haloalkene. Memang dia punya parents dan suffix still alkene. Tetapi due to the presence of polar bond between carbon and Cl, itu yang membuatkan dia jadi electrophile yang boleh undergo nucleophilic attack. Okay, instead of kalau dalam alkene kita ada free radical substitution, tapi bezanya haloalkene dengan alkene sebab dia ada polar bond ni, dia boleh buat nucleophilic substitution dan juga addition yang kita belajar semalam. Okay, so now the questions ask you tells for the following haloalkene, you need to label the nucleophilics and also the electrophilic side on the molecule. Okay, so yang paling penting sekali, awak kena label sebab dengan labeling partially positive, partially negative lah yang kita akan tahu ini adalah haloalkene, berbeza dengan alkene biasa. So dalam mekanisme apa sekalipun, start dengan labeling the partially positive and partially negative. So between the carbon, now we are looking at this carbon bearing the chlorine. Okay, between carbon and Cl, siapa yang akan ada highly negative, more electronegative atom? C or Cl? Cl. Okay, jadi kita letaklah partially negative. Okay, lepas tu yang carbon adalah partially positive.
Chlorine.
Okay, so the question number 2, yes. Question 2, the B, it asks you to explain why this compound is able to undergo nucleophilic substitution. Kenapa awak kata dia boleh buat nucleophilic substitution sedangkan kalau dalam alkene biasa dia ada free radical substitution sahaja. Apa yang kita nak cerita? Ada kaitan tak dengan polar bond ni?
Ada.
Kalau dia minta, ada. Bila dia cakap explain why this compound is able to undergo nucleophilic substitution, kita tengoklah nucleophilic substitution semalam yang kita belajar, nucleophile attack, Cl keluar. Maksudnya dia boleh pecah. Kenapa dia boleh pecah dan dia dapatkan Cl tu completely dapat electrons sebab dia orang undergo heterolytic cleavage. So heterolytic cleavage berlaku pada polar bond. Jadi awak kena cakap this compound ada apa? This compound contain apa? Kenapa kita kata dia buat heterolytic tu? Dia
Polar
contain?
bond.
Yes, contain polar bond. Dekat mana polar bond awak?
Carbon and Cl.
Yes, so kita boleh cakap the carbon bearing the Cl. So kita emphasize lah polar bond tu adalah benda ni. The carbon bearing the chlorine is susceptible. Maksudnya dia boleh di-attack sebab dia ada this difference in terms of electronegativity to nucleophilic attack. Kenapa dia boleh di-attack? Sebab sekarang bila dia partially positive, dia dah ada electrophilic site. Okay, jadi nucleophile with more electrons on them, they will attack donating the one of the lone pair to this electrophilic site of carbon. Okay, boleh Faham tak? Bila dia minta explain jangan fikir jauh-jauh. Kita tengah cakap kenapa dia boleh buat? Sebab carbon bearing the Cl ni lah. Itu je beza dia. Antara alkane biasa. Alkane pun substitution. Tapi sebab dia ni tak ada the difference in terms of electronegativity, susah untuk dia remove hydrogen. So dia hanya boleh buat free radical substitution. In contrast to this haloalkane, dia ada carbon bearing the Cl which is the polar bond, then they can proceed with nucleophilic substitution. Sebab kita faham nucleophile kita sekarang ni dalam kes ni kita nak bawa lone pair dan dia nak bagi dua-dua elektron. Jadi heterolytic cleavage sahaja yang dibenarkan. Boleh
Okay.
Alright. So kita proceed dengan non-face-to-face questions pula untuk second hour. Okay, ini basically reactions lah. Okay, reactions semalam kita belajar ada 3 jenis reactions involved in haloalkane. Eliminations, nucleophilic substitutions dan nucleophilic addition. Okay, jadi awak kena hati-hatilah. Dia bukannya kalau ditunjuk ni reactions tu apa saja. Dia boleh campur macam-macam. So awak kena kenal siapa reagent used. Barulah kita boleh tahu dia buat nucleophilic substitution or nucleophilic addition. Jadi dalam soalan ni walaupun dia minta awak draw saja, saya nak awak bagi tahu saya juga. Saya bagi tahu saya apa dia punya type of reaction, nucleophilic substitution ke, eliminations ataupun nucleophilic addition, dan juga saya nak awak tentukan dia buat SN1 atau SN2. Boleh?
Boleh, Miss.
Okay, right. Now, kita tengok the first one, A. Okay. A ni sekarang, we initially got carbon bearing the Cl here. Kita nak dapatkan carbon bearing the OH, right? So, what kind of nucleophile yang kita boleh guna sebagai A? Nucleophile apa yang kita boleh guna untuk A?
Nucleophilic substitution.
Okay, kita tahu kita akan undergo nucleophilic substitution. Good. Okay, what about the nucleophile to be added? Sebab dia minta awak suggest A. A ni sekarang siapa kita punya reagent nak guna? Reaction with siapa?
Sodium hydroxide.
Okay, it can be sodium hydroxide in aqueous state ataupun water kan?
Yes.
Tapi sebab kes ni dekat dalam soalan yang sama kita ada dah water dekat sini. Okay, jadi kita tak payah buat suggest water lah, kita suggest sodium hydroxide. So maksudnya kita dah boleh dapat dah jawapan untuk G kan? G kita akan dapat produk yang sama betul tak? Kita akan dapat this cyclopentane, together with it we have alcohol. Produk sama tapi apa beza? So this sodium hydroxide, it's a weak or strong nucleophile?
Strong.
Strong. Bila strong nucleophile, and look at the classes of alkyl halide you have in here. The carbon bearing the Cl, they are secondary or primary?
Secondary.
Okay, bila dia secondary, okay, pair up dengan strong. Which mechanism do you think they will proceed with? and secondary? Awak rasa SN1 or SN2?
SN2.
SN2. Okay, good. Sebab kenapa? Okay, awak nampak dia macam planar. Tapi kan kita pernah belajar yang masa carbon, dia basically macam ni lah. Okay, dia basically macam ni. Dia macam carbon, boleh potong. Tapi tak applicable pun, sorry. Dia macam, dia macam mana nak cakap ah? Dia tak sepatutnya lah kalau ikut soalan, dia tak akan minta awak buat mekanisme kalau melibatkan cyclic structure. Tapi kalau ikutkan secondary ni dan juga kita ada strong, somehow the nucleophile can still penetrate from the backside. Jadi kita boleh cakap dia boleh favor SN2, tapi jarang lah. Rasa takkan keluar pun soalan kalau dia bagi cyclic structure awak, carbon bearing the Cl2 belongs to cyclic structure. Tapi they can go for SN2 knowing that your secondary and strong pair up together, they can go for SN2 because we don't even know to what extent the bulky alkyl group should be. Okay, dia bukannya kita tengok kalau dia panjang je bulky, tak. Dia tak tengok macam tu. Kita tak tahu pun, tak ada kita cover untuk benda tu dalam syllabus kita. Alright, so sekarang kita check untuk G alang-alang sebab dia buat reaction sama. This is a weak or strong nucleophile for water?
Weak.
Weak. So weak and secondary kita akan go for SN1 or SN2?
SN1.
SN1, good. Right. Okay, so kita tengok the second one. We initially got this carbon bearing the chlorine. Now we have this methoxide ion, O negative CH3. So we have lone pair on here. So what do you think about this? Saya rasa semua reaction ni adalah nucleophilic substitution. So tak payah suggest lah the type of reaction. This O negative CH3 belongs to a weak or strong nucleophile.
Strong nucleophile.
Strong. So bila strong nucleophile pair up with secondary, they will go for SN?
SN2.
SN2. So sama je lah. Okay, kita dah tahu dah dia memang secondary dengan strong ke weak, tahu dah So kita punya B sepatutnya kita akan ganti masuk O dekat sini. We have CH3. Could you please tell me the classes of compound that you have formed in B? Apa class of compound kita sekarang? When you have this group? Recall the functional group, kita ada COC. To which classes of compound do they belong to? COC.
Secondary.
Yes, we have ether in here. Okay, next one. Kita ada this secondary alkyl halide to react with NH3 in excess. This NH3 in excess, they belongs to weak or strong nucleophile?
Weak.
Weak nucleophile. Jadi kita masuk je lah. Kita masuk sekarang ni, kita dapatkan balik ni. Kita akan masukkan NH3 ke kita masuk NH2 sahaja?
Masuk
Sebab
NH2.
Yes, NH2. Oh, saya lupa pula nak tulis dia punya side product. Yang ni akan dapat NH4 plus Cl lah, minus. Kalau yang atas tadi kita just keluarkan je lah. Ni plus Cl minus. Dia boleh jadi NaCl juga dalam kes ni. Kan? Dia plus NaCl sebab datang pada NaOH. Dia yang ni dapat Cl minus saja. Kalau ikutkan, kalau dia suggest produk, awak tak perlu pun bagi side product tu. Okay, this one pula. Kita akan guna alcohol. Alcohol is a strong or weak species?
Strong.
Strong. So, alcohol. Check. Alcohol sekarang ni, dia adalah neutral molecule. Dan out of the 7 nucleophile yang kita classify semalam, yang diconsider sebagai strong species hanyalah with negative charge. Now alcohol is a neutral compound. They are strong or weak?
Weak.
Weak, okay, good. So bila dia weak, dia akan go for SN1. Jadi kita akan substitute sekarang ni the OH ataupun kita nak ambil OCH2CH3 yang masuk kalau kita react dengan alkohol. Kita nak ambil OH ke kita nak ambil OCH2CH3?
OCH2, CH3.
Good. O, CH2, CH3. Walaupun dia alkohol, kadang-kadang kita rasa macam dia nak masuk OH tapi tak, awak kena tahu. Untuk dapat OH hanyalah dari hydroxide ion ataupun water sahaja. Selain daripada tu alkohol walaupun dia carry the OH, dia hanya akan ambil OR, the alkyl group. Okay. This one for E. For E kita tahu from carbon bearing the chlorine, kita akan substitute this species. What do we call this species? Apa nama spesies ni?
Acetate.
Ester.
Yes, acetate ion. This is ester. The class of compound for the product adalah ester, betul. Tapi yang untuk masuk adalah acetate ion. O negative. The one and only negative charge yang belongs to, yes, weak nucleophile. Walaupun dia negative charge tapi dia weak sebab kita ada yang sebelah tu carbon bearing the O. Okay. Lagi F pula. Yang F ni sekarang daripada Cl kita nak ganti dengan Cn. This Cn comes from strong or weak nucleophile?
Strong.
Strong. Jadi bila strong nucleophile, yes, strong nucleophile. Kita nak guna apa? KCN ke HCN? Kita nak guna
KCN.
Yes, KCN. Jangan guna HCN tau walaupun dia bawa CN. Dia tak cukup kuat pun untuk bawa. Sebab H tu nanti dia kan H kita tahu HCN kan weak acid. Nanti dia dissociate partially. Nanti dah tak ni lah. Dah tak dapatlah produk yang kita nak. Okay, habislah untuk reactions melibatkan nucleophilic substitution. So ada berapa? 1, 2, 3, 4, 5, 6, 7. All 7 nucleophile involved. Okay, next one. Okay, next one, the questions wants you to explain SN1 and SN2 mechanism in terms of, so kita ada species involved, order of reactions, and then we have reactivity of the haloalkane itself. Maksudnya kita nak tahu from methyl to tertiary ke, dia akan favor siapa lah. Okay, lepas tu effect of nucleophile, kita nak tengok apa yang akan terjadi pada the nucleophile tu. And then kita tengok intermediate species apa yang kita form. Masa kita dah buat mekanism, kita dapat yang pertengahan tu untuk dia proceed to the last step. Kita dapat apa? And then if the rearrangement is possible or not. Okay. So as for the species involved, so species involved dekat dalam SN1, semalam kita discuss SN1, kenapa nama dia SN1, kenapa nama dia SN2. So what about the species involved to determine the rate of reactions and order of the reaction? Kita guna apa? Berapa banyak species involved dalam ni dan siapa yang terlibat? Kalau SN1. SN2 nucleophilic substitution. Bila 1 dengan 2 dia bagi tahu awak tentang species yang terlibat kan?
Betul.
So kalau SN1 dia cakap during the rate determining step hanya satu species yang terlibat masa first step awak nak buat tu. Ini jadi boleh tak bagi tahu saya species apa yang terlibat? Kita ada antara dua je, haloalkane dengan nucleophile. Kalau SN1,
Haloalkane.
yes, haloalkane. Good. Kalau awak recall balik the mechanism, haloalkane. If you recall the mechanism, dia hanya during the first step yang nak determine the rate of reactions tu, hanya satu sahaja yang terlibat. Kita pecahkan the carbon bearing the halogen punya bond. Okay, untuk dapatkan carbocation ion. Okay, then for SN2, sebab ada dua species, maksudnya you have both haloalkane and also our nucleophile akan takes place. Dia akan terus substitute. Okay, right. And then what about the order of reactions? If SN1, what is the order? Sebab dia rely only on one species, jadi the order of reaction is?
First order.
First order, good. Second, SN2 adalah second order. Okay, in terms of reactivity of haloalkane towards this SN1 and SN2 mechanism. So we know reactivity of SN1 reactions, dia akan rely on apa? Semalam kita discuss. Macam mana kita tentukan yang that particular species got the highest reactivity towards SN1? Kita tengok apa?
Class.
Most stable carbocation kan?
Betul.
Okay, so jadi kalau kita tunjuk reactivity, who's got the greatest stability out of the 4 species? Siapa paling tinggi reactivity dia?
Tertiary.
Tertiary followed by
Secondary. Primary.
followed by
Methyl.
methyl. Okay, good. Okay, so kita tahulah reactivity of our haloalkane dalam SN1 paling dia akan favor adalah tertiary. Even for secondary pun kena check juga type of nucleophile awak apa benda. Okay, so kita akan go for the most stable lah usually untuk tahu dia punya reactivity. Okay, what about SN2? SN2 pun akan rely on most stable carbocation ke? SN2 kalau kita tengok type of alkyl halide, kita akan favor siapa? Based on apa? Kenapa kita pilih dia? Dia nak pilih siapa? Kalau SN1 kita pilih tertiary, the highest reactivity towards SN1. Kalau SN2?
Methyl.
Okay, methyl. Kenapa
Unstable.
pilih methyl? Kita nak check for steric hindrance kan?
Yes.
Yes, steric hindrance. Steric hindrance ni yang kita nak tengok. Size of the alkyl group tu mengganggu tak? Sebab SN2 mechanism, kita nak buat attack from the back side, from the opposite side. Jadi untuk dia buat attack dari arah yang berlainan, dia perlukan satu compound yang tak ada banyak gangguan. Dari segi senanglah dia nak penetrate masuk dari belakang. Jadi kita akan favor the least hindered. The least hindered belongs to methyl, followed by primary, followed by secondary. Dan untuk tertiary tak adalah sebenarnya, tapi kita taklah yang paling rendah dia. Sebenarnya tertiary tak akan berlaku. Tertiary confirm dia pergi bagi dekat SN1. Okay, what about the effect of nucleophile? Okay, the effect of nucleophile ni maksudnya whether you need strong or weak nucleophile. As for SN1, dia akan favor weak or strong nucleophile to be used untuk SN1 kalau kita determine the SN1, SN2.
Weak.
Tahu weaker strength nucleophile akan favor SN1. Okay, and then SN2 pula?
Strong.
Yes, strong nucleophile. Memang strong nucleophile is required lah. Okay, as for the intermediates, bila kita dah buat rate determining steps tu, the first steps, kita akan form the intermediate species. So SN1 mechanism, dia akan hasilkan what kind of intermediate species? Carbocation ion, good. What about SN2? Adakah kita akan dapat carbocation ion juga? Tak, kita dapat apa? No. Dia tak cakap pun carbocation ion as intermediate ke tak. Dia tanya intermediate apa je?
Transition.
Yes, the transition states. Okay, dia mesti ada intermediate barulah dia boleh dapatkan final product. Okay, transition state lah, dia not necessarily a species that contain positive charge or negative charge ataupun dia lone pair or not. There's still a state where you form an intermediate so that they can proceed to the final steps. Macam tu. Okay, lastly, the possibility for rearrangement. For the SN1 mechanism, since we have formed carbocation ion, is there possibility for carbocation ion to rearrange?
Yes.
Yes, possible. Okay, kalau SN2, kita form transition state, ada ke rearrangement?
Tak
No,
ada.
impossible.
Tak ada, so impossible for rearrangement to happen. So inilah basically untuk awak tahu SN1, SN2 ni ada apa. Okay. Now, let's proceed to the face-to-face question. Okay, this face-to-face question, is it the question, Rhea? Yes, so this face-to-face question, the learning outcomes, they want you to show the SN1 and SN2 mechanism of the given haloalkane. Okay, so kita tengok sekarang ni, you are given CH3CH2Cl, so saya dah tolong lukiskan dekat awak. Dia kan nak tahu dia buat mechanism apa, it's better for you to at least keluarkan this part. Untuk awak nampak dia class of alkyl halide dia apa. Okay, lepas tu you want to react with what kind of nucleophile, weak or strong. And then kadang-kadang soalan dah bagi produk tau. Produk dia bagi ke awak kadang-kadang dia bagi produk tu it's a hint. Okay, sebab ada sometimes dia tak bagi produk, nanti kita assume sebab ada species yang contoh secondary, they can go for SN1, SN2. Sometimes they gives you the product to give you hint to which mechanism do they belongs to. Macam tu. Yang saya bagi semalam tu, dia tak adalah applicable each and every time. Dia tengok juga hint apa yang dia bagi. Right, so sekarang you want to substitute Cl dengan OH. Okay, so dia bagi dekat sini sodium hydroxide. First tentukan dulu, what is the class of alkyl halide for this compound? Apa class of alkyl halide kita? The carbon bearing the Cl kita? Primary, secondary, or tertiary?
Primary.
Okay,
Primary.
So kita ada, yes, thank you. Kita ada primary alkyl halide to pair up with sodium hydroxide. It's a strong or weak species? Strong or weak nucleophile? Strong. Okay, now you have least hindered alkyl halide to pair up with strong nucleophile to form this kind of product. What kind of mechanism to be used? SN1 or SN2?
SN2.
SN2 mechanism. Okay, so jom kita buat SN2 mechanism kita. So our SN2 mechanism, kita kena guna wedge dash wedge line. Okay, so bila wedge dash wedge line, kita start dengan our carbon here bearing the Cl. Okay, carbon bearing the Cl, and then you have solid line here indicates it's on the plane. Lepas tu kita ada wedge dash dekat sini dan juga wedge line. Okay, agak-agaklah macam 109.5 degree tu. Okay, lepas tu kita letaklah mana-mana kita nak letak. Selalunya kita letak yang paling besar tu kat sini, CH3. Lepas tu kita ada apa? 2 hydrogens. Okay, now apa first steps yang kita kena buat sebelum kita nak attack dengan nucleophile? What is the first steps? What is the first step, class? Boleh ke terus attack?
No.
No, kena first show the bond polarity, right?
Yes.
Yes, put the partially positive and partially negative. Then only you can proceed to the next step, which is attack of the nucleophile. The nucleophile, okay, awak bila nak attack dari belakang, walaupun saya tahu awak boleh lukis straight macam ni, jangan lukis straight macam ni, kena curl. Okay, awak buatlah datang daripada atas ke daripada bawah ke, jadi nampak juga curl dia. Okay, kat sini. So saya nak attack dengan siapa? Dia bagi NaOH, maksudnya OH minus lah, lukis dia punya lone pair tu. So kita ada this OH minus, dah kecil pula, sekejap. Okay, kita ada this OH minus, this OH minus to attack from the back side and then break the bond between carbon and Cl. Okay, apa yang kita akan buat dekat sini? Atas arrow ni kena tulis apa?
Slow.
Slow.
Slow. Lagi? Slow saja. Rate determining step. Jangan lupa you tulis yang ni. Ni memang ada markah. Awak tulis slow je salah nanti. Okay. Lepas tu, lepas dah slow rate determining step ni, kita akan form our intermediate. Intermediate dalam SN2 mechanism tadi awak cakap dia adalah
Transition state.
yes, dia adalah transition state. So kita akan masukkan OH dari sini. So OH akan duduk kat sini lah. OH, lepas tu kita ada this dotted line. We have our carbon. Then we have our dotted line here. And we have our Cl to be broken. And then yang CH3 akan tertolak naik atas ni. Kita ada CH3. And then here we have our dash. Dan juga our line. Okay, make sure dia nampak macam triangle Ni hydrogen, ni hydrogen. Tutup balik. Okay, sebab sekarang ni during the transition state ni lah yang kita akan buat fully bond breaking. Okay, jadi sekali lagi kita akan tunjuk the bond breaking between carbon and Cl. But before that, please first denote with sekejap. So kita ada partially negative, partially positive and partially negative. Okay, and lastly, barulah kita akan dapat our product containing OH. But now, what will happen to your product? Adakah dia akan dapat sama produk tak macam tadi ataupun ada sedikit perubahan?
Ada perubahan.
Ada perubahan dari segi apa? Kat mana perubahan dia? Selain OH masuk, apa lagi yang kita nampak perubahan kat sini?
Inverse.
Yeah, they got inverse configuration. So inverse dia dekat mana? Only at the OH lah. But the OH dah masuk completely. Jadi kita akan tolak balik. Yang CH3 ni tolak balik ke sana. CH3. Yang ni kita akan tolak yang belakang tetap di belakang lah. Hydrogen. Then we have our line here. Hydrogen juga. Okay, so this is your final product lah. Okay, boleh yang ni untuk SN2 mechanism.
Boleh, Miss.
Okay, right. So the next one, yes, the next one, okay, the questions gives you the reactions of this compound. Dia cakap you ada CH3, CH3,
Miss.
apa nama compound ni bagi tahu saya. Yes, yes,
Tanya,
ya.
kalau
Yang
yang
tadi,
masa first step tu,
Teruskan.
Miss,
Ya, tanya saya.
kalau tak tulis dia punya lontai yang dekat OH minus tu, salah ke?
Sebab dia mekanisme wak dia sangat particular. Kalau mekanisme memang kena tunjuk. Sebab awak nak gerakkan dia, gerakkan siapa? Macam mana dia boleh gerak kan? Kita nak donate siapa kan, betul tak? Movement of electron. Maksud curly arrow adalah movement of electron. Jadi kalau kita tak tunjuk electron, dia dapat
thank you,
markah. Walaupun betul. Okay, right. Next, we are given this compound. Could you please tell me the name of this compound? What is the name of this compound to start with? You have it.
Longest carbon
Berapa?
chain.
3 kan? Bagi terus saya nama dia.
Propane.
Nama penuh. 1 bromo. 2, hai cepat.
Two dimethyl propane.
Yes. 2,2-dimethyl propane. Okay, so we have this 1 bromo 2,2-dimethyl propane. What is the class of this alkyl halide? They are primary, secondary. Okay, they are primary alkyl halide. Thank you. This primary alkyl halide to pair up with H2O. Okay, H2O is a weak or strong? Nucleophile.
Weak.
Weak nucleophile. So we know we have primary and also weak. Kalau ikutkan, primary is least hindered haloalkane. Jadi you can opt for SN2 mechanism. But then when you have this weak nucleophile to pair up, it is impossible for SN2 mechanism to take place. Okay, tu dah kita tahulah at least. Tapi tengok juga, dia bagi awak hint about the product, right?
Yes.
Yes, the hint about the product also tells you, also to convince you which mechanism do they belongs to. If they insist to stay at carbon number 1, then maybe lah, boleh lah SN2. Tapi sebab ni dah tak bagi, so kita tahulah tak boleh jugalah still. But then dia ada berlaku apa dekat sini?
Rearrangement.
Yes, rearrangement. Whenever you have rearrangement, mesti dia buat carboxyl ion. Bila dia mesti buat carboxyl ion, they will go for SN1 or SN2?
SN1.
Yes,
SN1.
SN1.
Yes, thank you. Mechanism. Okay, so kita akan buatlah kita punya mechanism kita. Okay, so kita ada longest carbon chain of 3 carbon, 1, 2, 3, and then one of them will have this Br. Okay, and then we have carbon on the carbon number 2. Okay, lagi. We are going to first buat apa dulu during the first steps? Terus pecahkan ke kena buat apa dulu? Kena?
Label.
Tentukan
label
partially negative, partially positive.
positive, partially negative. So sekarang kita akan break the bond between carbon and also the Br. Okay, this is the first step. Jadi this is the rate determining steps. So samalah macam tadi. Kita kena cakap this is a slow reaction and it belongs to rate determining steps. Okay. So dah kita dah keluarkan dia, kita akan dapat this carbocation ion. So we have 1, 2, 3 here. Okay. Lepas tu kita ada apa dekat sini? Positive charge, jangan lupa. So we have this positive charge of carbon. Now, when you have your carbocation ion, look for the possibility for rearrangement. Since the product already tells you that they're gonna involve rearrangement, can you please suggest to me what kind of rearrangement to be done here? 1, 2 apa? Tengok neighboring carbon. Your neighboring carbon, awak ada apa dekat dia?
Hydrogen.
Do you have hydrogen on your compound now? The neighboring carbon?
1, 2 hydride shift.
Do you have hydrogen on your carbon that I circled in green? No. Jadi possible ke hydride shift?
Oh tak.
Kalau ada hydrogen, at least satu pun baru kita go for hydride. If you got none of them, jadi go for
Methanate shift.
hydride and methanate? Yes, methanate shift,
Methanate.
CH3 minus. Okay. 1 to CH3 shift, saya tak muat nanti awak tulis bagi penuh situ. So kat sini kita akan tunjuk lah macam mana kita nak tunjuk dia. Awak nak gerakkan this bond pergi dekat carbocation ion kan? Macam tu. Jadi kita akan dapat 1, 2, 3. Okay, sekarang awak dah ada extra carbon dekat sini. Okay, ni kita ada satu sini. Jadi positive charge awak dah pergi ke sini, right? Betul tak?
Betul.
Yes, kita dah gerakkan dia. Okay, so sekarang ni awak boleh proceed lah dengan nucleophilic attack. Nucleophile awak datang pada water. Water is a weak nucleophile, so dia tak boleh immediately dapat final product. Dia mungkin akan melibatkan 2 step lah sebab dia nak hasilkan final product dia. So we have our OH2. Don't forget to show the lone pair because we want to donate one of the lone pair from this water to the carbocation ion. So kita akan bagi dekat sini. So from here, you will form 1, 2, 3, 4. So kita akan ada sini, sini. So let's say kita ada here lah our OH. Tinggal satu lone pair. Don't forget to denote the positive charge. Okay, positive charge sekarang belongs to O. Okay, jadi kita nak keep the O saja. Water ni bukan satu je molekul dia dalam tu. Water ada lagi. So mungkinlah dia boleh attack lagi dengan water. Let's say you have another water molecule here. We can take the hydrogen from the water to keep on the OH. So ni bagi balik kat dia. So nanti dapatlah final product awak. 1, 2, 3, 1. And then we have this methyl and also OH. So kita dah substitutekan OH dia. Dapat tak? Ya okay, check. 1, 2, 3, 4, good. And then at carbon number 2 tu kita ada CH3 dengan OH. Samalah. Right, so this is your final answer untuk question ni. Right, so for non-face-to-face question, this is the third hour tutorials. You need to arrange the following compounds in order of increasing reactivity towards SN1 hydrolysis reactions. And then when kita dah arrange the following compounds in order of increasing reactivity, kena explain your answer. Maksudnya kena explain about the trend. Why did you choose this compound to be the highest reactivity towards SN1? Kenapa yang satu lagi the lowest? Okay, first thing first, in order for you to determine whether they are going to perform SN1 or SN2, what kind of factors should you consider? Apa factors yang kita perlu tentukan when determining whether you're going to perform SN1 or SN2 mechanism? Factors affecting dia. There are 2 factors affecting a type of mechanism. What are they?
Strength of nucleophile.
Yes, first kita tengok type of nucleophile. Lagi satu?
Type and reactivity of alkyl halide.
Yang tu type of reactivity of alkyl halide tu depends pada type of nucleophile lah, classes of, sorry, saya tak dengar. Right, reactivity of alkyl halide. Classes of alkyl halide lah, senang kita tulis. Okay, classes of alkyl halide. So now you're given compound, so the first thing that you can determine is the classes of alkyl halide. Okay, we know these SN1 reactions, they are first order or second order reaction.
First order.
Okay, bila first order maksudnya during the rate determining steps, okay, only one molecule involves, only one species involved, which is the haloalkane. Okay, jadi bila dia hanya melibatkan satu species at a time, jadi dia melibatkan dua step mechanism. Bila dia minta dua step mechanism, maksudnya dia ada beberapa benda yang dia akan form. Okay, maksudnya dia tak rush lah untuk immediately buat. Jadi SN1 usually kita favor for weak nucleophile lah. But you can also use the strong nucleophile, tapi depends juga. Okay, depends kepada awak punya type of classes of alkyl halide. Okay, now look at your compound here. Before we classify them into classes of alkyl halide, could you please tell me the name of this compound? We'll start from the left. Let's say saya define dia as compound A, compound B, and compound C. Okay, could you please tell me the name of compound for compound A? What is the name of compound A?
1-bromohexane.
Apa dia? Kita ada carbon number 1 here, so nama dia?
1-bromohexane.
Terus, 1-bromo.
Oh, cyclohexane.
Habis tu yang ni?
Oh, 1-bromo, 1-methyl, cyclohexane.
Okay, good. Thank you, Karunisa. Okay, orang lain pula. Saya nak compound B. Tadi 1-bromo, 1-methyl, cyclohexane. Orang lain compound B?
1-bromocyclohexane.
1-bromocyclohexane, thank you. Orang lain pula compound C? Compound C, anyone? Can you please name them? Macam mana? Apa nama dia? Tak nak try? Awak tak nak try ke?
1-methyl bromocyclohexane.
1-methyl bromo. 1-methyl bromo cyclohexane. Okay, betul. Methyl dulu ke? Kita ada ni. Dia akan jadi math kan? Methyl. Kat carbon number 1, bromomethyl lah kan? Ke tak? Okay. 1 bromomethyl cyclohexane. Okay. Right. So untuk case apa kita panggil ni? Case trending in terms of the physical properties ke ataupun reactivity ke yang kena susun a trend ni, kita tak semestinya kena guna nama compound tu, okay? Macam dalam case ni saya denote dia sebagai 1-bromo 1-methyl cyclohexane, saya boleh cakap dia compound A. 1-bromo cyclohexane compound B, 1-bromo methyl cyclohexane compound C. Okay, bila awak dah define dia sebagai A, B and C, awak dah bagi tahu siapa A, siapa B, siapa C, walaupun tak bagi tahu nama apa, kita boleh terus guna dalam kita punya explanation. Maksudnya you dah perkenalkan, you have defined to which alphabet do these compounds belongs to. Jadi explanations kita boleh je terus guna A, B ataupun C. Okay, right. So sekarang ni lepas dah tahu, kita dah try naming this compound, kita kena tentukan class of alkyl halide. So now your classes of alkyl halide can be determined from carbon bearing the Br. Kita nak tengok berapa banyak alkyl group attached to it. Okay. So, could you please tell me the first carbon and the first compound A, what is the class of alkyl halide? The carbon bearing the Br, how many alkyl group attached to it, the carbon?
Primary.
Primary, awak tengok kat sini kita ada 1, kita ada 2, kita ada 3. Primary ke?
Tertiary.
Tertiary.
Yes, tertiary. Awak kena tengok carbon bearing the Br. They are directly attached to siapa? Okay, kita bukan nak lukis enantiomer ke apa kan, masa kita tentukan enantiomer, kita tengok different pathway, tapi dalam kes ni tak perlu kita tengok siapa yang di attach tu, sebab by right, this cyclic structure memang boleh kita potong macam ni pun. Tapi dia bukan nak tengok sama ke tak, dia nak tengok berapa banyak keliling dia. Okay, this is a tertiary alkyl halide. Okay, what about compound B, 1-bromocyclohexane? What is the class of alkyl halide?
Secondary.
Secondary because you got 2 carbon attached to it. So this is secondary alkyl halide. What about the C?
Primary.
Yes, primary. Okay, so as for SN1, because it involves 2 steps mechanism, which of these 3 compound do you think will favor SN1 mechanism? Who's got the highest reactivity towards SN1 mechanism? A got the highest ke? Kenapa awak cakap A? During the 2 steps mechanism, what kind of intermediates to be formed? Bila kita remove kan Br ni, kita akan form intermediate jenis apa? Yes, carboxyl ion. So you have to bear in mind when it comes to SN1 mechanism, factors affecting their reactivity relies on the stability of carboxyl ion. Okay, bila carboxyl ion awak lagi stabil, sebab carboxyl ion is a electron deficient species, jadi bila dia dikelilingi oleh banyak alkyl group, dia akan jadi lagi stabil. Okay, kita boleh cakap yang A has the greatest stability, followed by
B.
followed by B, and then followed by
C.
C. Okay, good. Okay, ataupun awak boleh buat C, B, A. Okay, lepas tu dia ke arah kanan, increasing reactivity towards SN1 mechanism. Even for the one yang kita guna simbol tu, tolong pun juga buatkan sikit kepada dia. Reactivity towards SN1 mechanism. Tu buat mechanism. Okay, macam tu. Bagi tahulah benda apa. Right, tu awak baru arrange. Now dia minta awak explain. So kita tahu C yang paling tinggi dia punya reactivity towards SN1 mechanism. Kenapa? So how do we start explaining this? Tadi kita cakap the stability will rely on carboxyl ion kan?
Yeah.
You can start explaining them by first mentioning siapa yang paling stable. Okay, kita boleh cakap tertiary. Kita bagi general statement dulu. Okay. Tertiary carboxyl ion is the most stable. Sebab apa? Kenapa
More
dia?
alkyl group attached to carbon.
Yes, it's the most stable. Kita boleh cakap because stability of siapa yang kita tengah cakap sekarang? Stability of
Carbon.
Yes. Carboxyl ion increases with increasing number of siapa? Number of siapa yang kita nak tambah kalau nak bagi stable?
Electron.
Yes, alkyl group. So first awak bagi dulu general statement yang mempengaruhi stability, the reactivity towards SN1 mechanism. Okay, lepas tu baru kita cakap tentang kita punya compound yang terlibat. So kita boleh kata yang compound A Okay, compound A with, okay, ni kita buat siap-siap lah, kita bagi guna dia ni, tertiary. With tertiary carbocation is the most stable kan, has the greatest, so kita cakap
Stability.
bila ni kita nak cakap asal reactivity, has the greatest reactivity. Okay, bagi tahu ni dulu. Has the greatest reactivity towards SN1 mechanism. Okay, compared to siapa tadi? Siapa lepas A?
B.
Compared to B, buat dalam kurungan bagi tahu dia adalah secondary carbocation, sebab kita kan kena bagi tahu carbocation and compound C. Okay, compared to B and compound C. Compound C bagi tahu dia primary. Bila awak dah bagi tahu dia carbocation apa, awak tak boleh cakap dah yang B lagi stabil ke apa, sebab kita dah bagi tahu dekat atas tu yang stability dia bila kelas dia punya carbocation tu makin banyak alkyl group. So kita faham lah carbocation kalau primary ada satu sahaja. Okay, bila awak dah cakap tertiary carbocation more stable bila banyak alkyl group. Jadi bila dia banyak alkyl group, dia akan has the greatest reactivity towards SN1 reaction. Jadi bila dia greatest reactivity towards SN1 kita nak buat apa? SN tu belongs to apa? SN. S tu apa?
Substitution nucleophilic.
Substitution dan nucleophilic. Jadi kita nak cakap lah yang bila stabil, okay, awak boleh cakap the most stable the carbocation, okay, the more susceptible. Yakni term ni dia guna untuk bila kita nak kena attack lah. The more susceptible it is for nucleophilic attack, untuk nucleophile attack, sebab dia dah create that electrophilic site yang sangat yang macam nak terima electrons tu. Okay, so okay ke untuk explanation ni faham? Dia cerita dulu siapa yang affect, kita kata carbocation punya stability, compare kan dalam awak punya case tu kena relate, bukan cakap pasal stability sahaja, kena relate dengan reactivity sebab kita tengah cakap tentang SN1 mechanism. Dan baru bagi tahu bila dia stable, bila dia dah ada highest reactivity, apa yang dia nak buat sebenarnya bila dapat this stable carbocation, bagi tahu yang dia akan favor this nucleophilic substitution. Boleh?
Boleh.
Right. So, sekarang ni kita tengok pula the second question. Still on reactivity towards the reaction, but now we have SN2 mechanism. When we say 2, dia adalah nucleophilic substitutions involving two species at a time during the rate determining step. Boleh tak saya tahu siapa two tu? What are the two species involved?
Haloalkane.
Yes, haloalkane dan juga nucleophile, your nucleophile. Okay, so this haloalkane and nucleophile pula, kita tengok dia tak sama dia punya reactivity macam SN1 sebab the intermediate species form is different from one another. Can I know what kind of intermediate species to be formed in SN2 mechanism?
Transition state.
Yes, transition state. So untuk kita dapatkan transition state, kita akan proceed with backside attack. Maksudnya attack dari belakang. Jadi bila kita nak masuk ikut pintu belakang, kita kena ada satu jalan yang luas untuk kita masuk. Sebab dia agak susah lah, instead of kita masuk pintu depan dengan pintu belakang. Pintu belakang ni dia macam pintu yang orang tak buka. Jadi kita kena pilih yang satu molekul yang bagi ruang dekat kita. Jadi ruang tu dia affected by your alkyl group attached to it, whether they got branch or straight chain. Okay, bila ada branch lagi susah lah kita, lagi banyak gangguan untuk kita cuba untuk masuk. Kalau straight chain, walaupun bilangan karbon sama, straight chain lebih mudah sebab dia tertumpu pada upper side sahaja, only one part. Okay, still got spaces for them to attack the nucleophile. Okay, jadi sekarang ni namakan dulu compound ni. This compound, so kita denote juga, this is compound A, compound B and compound C. Right. Jadi compound A, compound B and compound C. Look at compound A here. What is the name of this compound? We got 1, 2 and 3, the longest carbon chain. So what is the name of this compound?
1 bromo,
Okay,
2
1 bromo.
methyl,
Yes.
propene.
Methyl. Propene ke propane?
Propane.
Propane. Good. Okay, compound B pula. How to name this compound B? 1,
1
2,
bromo, pentane.
1 bromo. 4 ke 5 tu? 4 karbon
4.
Jadi pentane ke?
Butane.
Butane.
Butane. Yes, 1 bromo butane. Good, thank you. Lagi satu. Sekejap. Lagi satu kita ada the longest carbon chain 1, 2, 3. So nama dia
1 bromo,
mm
2 dimethyl.
Okay, kalau guna di maksudnya kena ada dua nombor.
1 bromo, 2
Yes,
dimethyl
dimethyl.
propane.
Yes, propane. Okay, so that's how you name your compound lah. Okay, so we have these different compound to one another. Jadi, SN2 mechanism will favor the alkyl halide that is less hindered. Bila sebut less hindered ni, kurang dari segi dia punya gangguan untuk kita attack dari belakang tu. So kita tengoklah, if you got branch maksudnya banyaklah gangguan dia, agak besar, susah. Okay, so kita sekarang check dulu. The carbon bearing the Br now, what is the class of alkyl halide? Untuk compound A. Ada berapa carbon attached to dia?
1.
Satu, tetapi awak tengok size of the alkyl halide here. Okay. Right, so kita tengok dekat sini, our branch, our alkyl group attached to it got 3 carbons. Okay, this is the first hint. And then what about this one? Our alkyl group is just straight chain, right?
Yes.
It got how many carbons?
3.
3 carbon as well. But the difference between these two adalah branch and also straight chain. Okay, the last one. The last one here, the carbon bearing the Br, what is the alkyl group attached to it? How many of them? So what is the class of alkyl halide?
4 carbon.
4 carbon. Okay, this one got 4 carbon. Tapi ini adalah primary. Yang ni pun primary, right? Yang ini pun primary. Betul tak?
Yes.
Semua primary. Okay, bila semua primary, kita kena tengok pula bukan pada size, tapi kita tengok pada dia punya alkyl group tu sama ada straight chain or branch. First kita check yang tu dulu. Okay, jadi sekarang awak tengok kita ada 1 4 carbon, satu lagi 3 carbon. Okay, tengok dulu yang 4 carbon sebab size dia besar. Okay, 4 carbon ni dah lah besar size dia dan dia branch. As compared to 3 carbon yang branch, siapa yang lagi besar? 4 ke 3?
4.
4. Jadi kita boleh cakap sebab dia minta soalan dia apa? Decreasing reactivity. Bila decreasing reactivity towards SN2, paling kanan yang paling tak possible untuk buat SN2. So awak rasa antara A, B dengan C, siapa yang paling rendah dia punya reactivity towards SN2? Paling yang kita tak nak lah.
B.
Apa? Yang paling rendah, paling rendah. Paling rendah bukan rendah size. Paling less possibility to perform SN2. Tadi kita cakap SN2 ni nak backside attack. Bila nak backside attack, perlukan ruang yang banyak. Kalau saiz dia besar, ruang yang tinggal sikit ke banyak besar?
Sikit.
Jadi sekarang ni kalau kita nak susun this trend, decreasing reactivity makin ke kanan, makin yang sikit ruang yang tinggal.
Faham Miss.
So jadi siapa yang paling sikit ruang dia antara A, B dengan C?
C.
C. Lepas tu followed by
E.
A and then followed by
E.
B. Okay, so kita dapatlah this is our trend for decreasing reactivity towards SN2 mechanism. So buat sikit decreasing, kita ada reactivity towards SN2. Buat sikit. Ataupun B, A, C. Ke arah ni, decreasing reactivity towards SN2. Okay, so kita nak explain sekarang ni. So first kali bagi tahulah yang diorang ni semua sama. Okay, semua sama, so kita boleh cakap as for the first point, tentang the reactivity dia tentang steric effect kan. So boleh cakap dulu, first, all molecules, okay, they are primary alkyl halide, is it?
Yes.
Okay, tetapi siapa tadi yang paling slow reaction rate dia? Paling rendah C kan?
Yeah.
But compound C has the slowest rate of reaction as compared to siapa lepas C tadi? Lepas C tadi A ke B?
A.
Okay, as compared to A and B. Okay, kenapa? Okay, buat ayat bersambung. This is because, kenapa tadi awak tengok? This is because,
The size.
okay, the size of the alkyl group kan?
Yeah.
Okay, the size of alkyl group, buatlah rangkuman sikit, kita kata third butyl. Sebab kita dah tahu kan nama dia yang kalau branch, third butyl attach to the alpha carbon. Bila kita kata carbon bearing the Br ke apa, itulah carbon pertama. So kita panggil dia alpha carbon. Okay, attach to the alpha carbon ataupun carbon bearing the Br awak pun kita terima, tapi saja saya nak bagi awak try guna term ni. Okay, the size of alkyl group attached to the alpha carbon is the biggest, is the largest, okay, largest, hence giving greater steric effect. Okay, hence giving greater steric effect. Okay. So, bila cakap hence giving greater steric effect, apa yang steric effect ni akan buat? So, boleh sambung. Awak boleh kata, having greater steric effect makes it difficult for nucleophile to attack from the opposite directions ataupun from the back side. Okay, the direction. Okay, boleh ikut saya the explanation here?
Boleh, Miss.
Boleh, Miss.
So, dia sebenarnya cerita balik je lah, bagi tahu tentang factors affecting the stability antara SN1 dan SN2, lepas tu baru kita relate, lepas tu buat conclusions yang relatekan balik kepada the mechanism. Okay. Sebab kita akhir sekali kita nak buat nucleophilic substitution, so kena bagi tahu senang ke susah ataupun susceptible to be attacked or not. Okay, right. So kita proceed to the final hour. This final hour will involve the nucleophilic additions reactions. Okay, in order for you to do the nucleophilic additions reactions, they will involve the haloalkane, but then, dia bukannya directly on the haloalkane. You must first form the Grignard reagent. Asalnya haloalkane, modify jadi Grignard reagent, then only can proceed with the nucleophilic addition. Okay, so yang akan jadi nucleophile adalah the Grignard reagent itself. Okay, tetapi untuk first question ni dia belum lagi Grignard, it's just another reactions involved Yang sebelum ni nucleophilic substitution. This one, boleh tak bagi tahu saya from this question dekat dalam screen ni, okay, untuk fourth hour, fourth hour face to face. These reactions belongs to which reaction? Reaction ni type of reaction. Give the structure of product when 2-chloro-2-methyl-butane is reacted with hot alcoholic potassium hydroxide. Ini apa type of reactions dia? Kita ada 3 semuanya. This belongs to siapa? We have nucleophilic substitutions. We have nucleophilic additions. The other one belongs to?
Elimination.
Yes, elimination. So eliminations here involve the dehydrohalogenations of the haloalkane. You start with this haloalkane to react with this reagent and then to form multiple bond, which in this case the alkene. So boleh tak tolong saya lukis 2-chloro-2-methyl-butane. So how many carbons that makes up the parent chain?
4.
4. Because of the butane, we got 4 carbon. 1, 2, 3, 4. Okay. And then at carbon number 2, let's say we start from the left. Okay. At carbon number 2 here, we have 2 substituents. Can I know who are their substituents?
Methyl,
Yes.
chlorine.
Yeah, thank you. Chloro and methyl. Okay, jadi sekarang ni dia kata is reacted. Maksudnya is reacted. Now dia nak buat reactions. Kita kena ada this reactions arrow. Okay, dia melibatkan hot alcoholic potassium hydroxide. So we have this potassium hydroxide. Dia cakap alcoholic, they are dissolved in ethanol and they must be hot. So we use this reflux setting. Okay, knowing this as your reagent, okay, you aim to find the double bond, is it?
Yes.
Yes, so the first carbon to involve is this carbon bearing the Cl. Okay, means kalau kita nak buat double bond, look at the adjacent carbon. So the adjacent carbon now we have 2 of them. One in here, another one in here. So how many possible product of alkene are we going to get? Are we going to get a mixture or only one product? If we have 2 neighboring carbons from this carbon bearing the Cl.
Mixture.
Mixture, how many of them? We have three neighboring carbon, but then how many products to be formed, do you think? Are we going to form 3 carbons and 3 products?
2.
2 only because they got the same environment, okay? Yang antara 1 dengan 1 tu. 1 dengan 2. Okay, jadi sekarang kita form lah, kita lukis balik. 1, 2, 3, 4. Okay, 1, 2, 3, 4. And then kita keepkan the methyl here. Right, apa yang kita akan buat? We form first here double bond. And then the other product kita akan dapat 1, 2, 3, 4 juga. But now your double bond is in between carbon number 2 and carbon number 3. Okay. Now, bagi tahu saya, what is the name of rule that we use to determine the major product? What is the name of rule that we use to determine the major product?
Shazaf rule.
Yes, Shazaf's rule. Okay, Shazaf's rule cakap alkene yang paling banyak substituent akan jadi major product. Sekarang ni siapa major product? Kiri ke kanan?
Kanan.
Kanan sebab kita ada 1, 2 and 3 alkyl group. Okay, kalau kat sini kita only got 1 and 2, maksudnya substituents lah. Okay, so this gonna be the major product. Kita ada tak belajar mekanisme untuk dehydrohalogenation? Do we have mechanism for dehydrohalogenation?
Yes.
Untuk elimination kita memang ada mechanism tapi bukan untuk dehydrohalogenation. Untuk mechanism elimination kita hanya ada dehydrations, okay? Tak ada yang ni. Untuk dehydrohalogenation tak ada. Alright, so kita proceed dengan soalan seterusnya. Tadi third hour, sorry. This is the fourth hour. Ni baru nak masuk nucleophilic addition. Now, Grignard reagent is an example of organometallic compound which is very useful in the synthesis of many organic compounds. So, dia cakap, bila ada Grignard reagent, dia boleh buat synthesis of organic compound. Can I know organic compound apa yang dia boleh buat? Tell me the class of compound yang boleh kita form daripada Grignard reagent. We want to synthesis them.
Alkane.
Kita boleh buat antaranya, yes, thank you. Kita ada alkane. Then we have alcohol. And lastly, kita ada?
Carboxylic acid.
Yes, carboxylic acid. But can you simply take the haloalkane even though the questions ask you to form from haloalkane to become carboxylic acid, let's say. Okay, you know they are part of the reactions in haloalkane. But can you simply write the Grignard reagent without showing how are they prepared? Boleh tak? Maksudnya terus awak soalan bagi yang ni je, terus awak buat CH3, CH2, MgBr, terus macam ni without showing the preparations of Grignard reagent. Boleh tak macam tu?
No.
Tak boleh, dia kena prepare in situ. If the questions only give you this compound, means you need to show first how the Grignard reagent is prepared, then only you can proceed to the nucleophilic additions. If not, markah akan ditolak sebab awak tak show. Sebab diorang ni prepared in situ. Kita kena tunjuk. Okay? Right, so sekarang ni soalan dia. Show the preparations of the Grignard reagents sahaja. So, Grignard reagents ni, can I know they are going to react with siapa? Your haloalkane, kita nak react dengan siapa? Kita nak react dengan siapa? Haloalkane kita? To form Grignard?
H2O.
Itu kalau Grignard dah react dengan water. Sekarang ni baru nak prepare the Grignard. Okay, sekarang soalan dia, show the preparations of Grignard reagent.
Dry ether.
Dry ether is the conditions dia. Kita nak guna apa? Siapa yang kita nak masukkan? Kita akan modify this structure.
Mg.
Yes, we use this Mg metal, okay? Mg with the presence of dry ether. With the presence of dry ether, then only we can form our Grignard reagent, CH3, CH2, MgBr macam tu. Sebenarnya MgBr ni dia ada positif negatif lah. Tapi tak apa, kita tulis dia macam ni. Lagi, kalau yang ni pun sama juga. Magnesium. Kita akan prepare under the conditions of dry ether. Okay, barulah kita akan dapat. So, awak lukis balik yang haloalkane tadi tu, but kita letak in between dia adalah Mg dan juga lukis ni Cl. Boleh ke? Mg mesti duduk tengah sebab dia sebagai metal yang hold the compound.
Boleh.
Okay, so we have now prepared our Grignard reagent. Okay, kena buat benda ni walaupun soalan tak bagi. Tapi kalau lalu dia kena tunjuk. Okay, sekarang kita kena determine the structural formula of our product. Okay, dia dah bagi siapa reagent, siapa dia punya conditions. Okay, bukan dulu. Kita belajar masa tulis reaction, kita buat nombor 1, contoh aldehyde kita. Nombor 2 adalah kita terus ether, H2O plus kan. Okay, dia ada dua cara lah. So saya rasa better guna yang ni, tak adalah awak tersilap ke apa nanti. Yang ni, kalau awak tulis ni tambah your compound, awak kena ada balik ether ni. Sebab kita nak dia dalam keadaan yang tak ada air. Kalau sebab dia satu ni buat satu-satu. Satu dengan dua ni maksudnya dia buat one by one. Itu kalau awak guna tambah ni lah. Kalau awak tak guna macam ni, terus buat atas arrow, your aldehyde and your ni dah tak perlu dah tulis ether. Okay, itu cara penulisan.
Okay.
Alright, so sekarang kita proceed dengan what kind of product to be formed. Okay, now you are given what's here. Ini adalah haloalkane or Grignard reagent?
Grignard.
Grignard. So bila you are given Grignard, can you proceed to do the nucleophilic addition?
No.
You already have your Grignard. Now, all these reactions kita kalau melibatkan ni, kalau kita nak buat ni kan, bila ada this aldehyde, okay, ni aldehyde kan?
Yes.
Okay, bila melibatkan aldehyde, kita masih buat nucleophilic substitutions ke? Yang macam kita buat SN1, SN2 tu?
No.
No, kita akan buat apa reaction dia? Kita dah buat nucleophilic substitution, kita dah buat elimination, tinggal?
Addition.
Yes, nucleophilic addition. Jadi bila dia nucleophilic addition sekarang ni, awak mesti guna Grignard reagent. Sekarang, soalan dah bagi belum Grignard reagent?
Ya.
Boleh tak terus buat nucleophilic addition?
Boleh.
Teruslah. Yang tak boleh terus buat kalau dia bagi awak haloalkane. Buat dulu Grignard baru boleh react. Okay, so when this Grignard reagent to react with this aldehyde. So this aldehyde here, kita tahu aldehyde got carbonyl group. This is your carbonyl group. And then we have at least one hydrogen directly attached to it. Itu dah maksudnya aldehyde. Tapi bila kita ada dua aldehyde kat sini, dua hydrogen, what kind of product to be formed awak rasa? Kalau kita react dengan carbonyl group, kita nak dapatkan apa? Alkane, alkohol atau carboxylic acid?
Carboxylic acid.
Carboxylic acid? Carboxylic acid kena ada 2 O. Sekarang carbonyl group ada 1 O sahaja.
Alkohol.
Alkohol kita ada berapa classes? How many classes of alcohol do we have? Kalau kita tengok dari synthesis of alcohol tu, dia bagi berapa?
One.
Awak tengok balik. Awak tengok balik nota. Ada berapa classes of alcohol? 3. Jadi, awak kena form, bila kita kata primary alcohol, secondary alcohol, tertiary alcohol, samalah macam primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. Okay, awak kena faham sekarang, nak buat alkohol, kena ada at least 1 O. Datang pada mana 1 O? That 1 O comes from this carbonyl group. Okay, kalau awak kata carboxylic acid, you don't even have 2 oxygen in here. That's why it is not possible to synthesize carboxylic acid from only aldehyde or ketone. Got it?
Yes.
Yes, okay. So sekarang ni you only have 1 O. Maksudnya you akan secure to form alcohol. But now what class of alcohol to be formed? Kita kena tengok class of alcohol, carbon bearing the OH nanti ada berapa banyak alkyl group attached to it. At the moment you have your aldehyde with 2 hydrogens. When you want to add this Grignard reagent, how many alkyl group do you think you are going to add? Berapa banyak alkyl group yang kita akan tambah bila kita masukkan this Grignard reagent? Only one. So kita nampak dekat Grignard ni, okay, dekat Grignard ni kita akan masukkan this one alkyl group sebab kita nak pecahkan the bond between carbon and also this MgBr. So kita akan masukkan 1. Bila awak nak masukkan 1 dan dekat atas carbonyl group awak ni awak ada 2 hydrogen. Which class of alcohol to be formed do you think? Primary. Okay, jadi apa yang dia akan buat dekat sini? This bond, okay, this bond, kita nampak dekat this carbonyl group, bila dia buat nucleophile addition, dia akan jadi electrophile. Grignard adalah nucleophile, ini adalah your electrophile. So bila electrophile dia akan kena attack, maksudnya kena ada that electrophilic site. This going to be your partially positive, this going to be your partially negative. So this bond will break and then takes up the carbon and then break the bond between this carbon and oxygen, left with only one single bond with extra electrons on here, then they will become negative charge. And then if we further expand this OH3 plus, okay, this O will take this hydrogen and pecahkan dia. So kita akan dapat apa dekat sini? We lukis balik kita punya structure. We have this carbon bearing the O, bearing the H and H. Okay, lepas tu kita ada O ni akan jadi OH. And here tengok dia masuk berapa carbon? Dia masuk kat carbon nombor 2 kan?
Yeah.
Ya, maksudnya sebelah karbon nombor 2 ada 1. So awak boleh buat 1. Lepas tu satu lagi 1, 2. Kan? Cuba check balik. Make sure tally. Okay, if you here got 1, so you got 1 in here as well, right?
Yes,
Sini ada 2, kita masuk 2, betul tak?
betul.
Yes, this is your compound H. So kita tengok sikit dia punya side product dia. Side product dia adalah kita akan form MgOH dan juga Br, is it? MgOH2 ke? Tak ingat dah. Kan? Tak apalah, kita tak payah buat yang ni. Tapi side product lah. Okay. Boleh awak?
Boleh ni.
Right.
Boleh ni.
Now, kita tengok ni pula. Do you have your Grignard reagent now?
Yes,
Yes. So this Grignard reagent will carry one alkyl group to be added to the carbonyl group. On your carbonyl group now, this is aldehyde or ketone? This is aldehyde or ketone?
aldehyde.
So aldehyde. Your aldehyde got alkyl group attached to it or not?
Yes.
Yes, jadi kita akan contribute another alkyl group. So when you are going to form your alcohol, which class do you think do these reactions belongs to? Bila ada 2, dia akan dapat alkohol jenis apa?
Secondary.
Secondary. So macam mana nak lukis? Kekalkan carbon bearing the O. We have 1 hydrogen and also here you have your CH3, right? Your alkyl group. This O will become the hydrogen OH and then this one sambung je balik, tengok kita tambah apa? Kita ada benzene. Terus je lukis. 1, 2 and 3. So by having these 2 alkyl group, they belongs to secondary alcohol. 1, 2. Yang tadi 1 only. So this is primary alcohol. This is secondary alcohol. So primary and secondary alcohol can be formed by reacting Grignard reagent and also aldehyde. But for primary alcohol, the only aldehyde yang are capable to form this primary alcohol hanyalah methanol. Only 1 carbon with 2 hydrogen attached the carbon bearing the O. Okay, kalau yang untuk secondary baru kita boleh start from ethanol, 2 carbon. Okay, next one. So the last part of this tutorial, kita ada this compound. This compound is a Grignard or not? You are about to react with this carbonyl group, maksudnya kena buat nucleophile addition. But at the moment, do you already have your Grignard reagent?
No,
Not yet.
No.
Jadi bila not yet, boleh kita terus buat reaction, buat nucleophile addition without first modify them into Grignard reagent?
no, boleh.
Jadi kena buat apa dulu?
Kena tambah dengan Mg.
Yes, with the presence of
Dry ether.
dry ether. Okay, Mg dry ether. Okay, kalau boleh sekejap. Tukarlah kita guna plus Mg. Nanti takut ada isu pula sebab dia ni plus Mg and then kita ada this dry ether. Okay, your dry ether now, kita akan dapat, nak dapat pula sekejap This dry ether, kita akan masukkan Mg in between. So we have CH3, CH2, CH2, Mg in between the haloalkane, Br. Now you have formed your Grignard reagent. Can they proceed with the nucleophilic addition?
Yes.
Boleh.
Yes. The bond between carbon and also the Mg will be broken. Dia akan dapat masuk dekat sini, break the bond here, and then kita ambil hydrogen. So now you have how many alkyl group attached to your alcohol? The carbon bearing the OH nanti. Ada berapa agak-agak?
1, 2,
1, 2, 3 kan?
oh ya.
Ya, jadi kita akan dapat what class of alcohol?
Secondary.
Secondary? Awak dah ada 3 takkan secondary?
Tertiary.
Carbon bearing the OH directly attached to it, kita salin balik CH3, CH3, and then yang bawah ni tengok masuk dekat carbon yang pertama tu, so masuklah CH2, CH2, CH3. So this is your tertiary alcohol because you got 1, 2 and 3 alkyl group attached to the carbon bearing the OH. Okay, so preparations of tertiary alcohol can be made from the Grignard reagent to react with only ketone. Tak boleh aldehyde sebab ketone dia nak 3. Okay. Next one, we have this compound. We have this compound of haloalkane to react with sodium hydroxide. Is this is part of nucleophilic additions reaction? Is this reagent used in nucleophilic addition?
No.
No, this is simply what is the type of reactions involved? When reacting haloalkane and sodium hydroxide, what type of reactions involved?
Nucleophilic substitution.
Yes, nucleophilic substitution. This is simply nucleophilic substitution. So bila kita react dengan the sodium hydroxide is a weak or strong nucleophile? Strong nucleophile. If you have strong nucleophile, and then what is the class of alkyl halide here? Carbon bearing the Cl.
Primary.
Primary paired up with strong nucleophile. What kind of mechanism? Primary and strong nucleophile. Mechanism apa yang kita nak proceed with?
SN2.
SN2 mechanism. Good, thank you. Jadi kita simply substitute saja this Cl to be substituted with this OH. Okay, kekalkan dia. So kita akan ada 1, 2, 3. Okay, sini kita masuk OH kita. Right, the last one. You have this Grignard reagent. Okay, Grignard reagent now. You want to react them with CO2. CO2 we know. On CO2 we got two oxygens, C11O. Okay, so this is partially positive, partially negative. So this carbon bearing double bond O akan jadi the electrophilic side. So kita akan dapat apa dari sini bila ada 2 oksigen? Adakah kita akan dapat alkohol lagi? Tak, kita akan dapat
Carboxylic acid.
yes, carboxylic acid. So kita pergi dekat this carbon, the one O, kita pecahkan bond ni, nanti this O dia akan ambil one of the hydrogen here. So lukis balik, kita ada C double bond O, buat dulu. C double bond O, O kat sini dah jadi H. Okay, kita akan masukkan siapa? So kita masuk dekat carbon tengah ni, okay? So awak pun lukis balik. Carbon 1, 2, 3. CH3, CH3, CH3. Okay, this is your carboxylic acid. Okay, habislah untuk kita punya tutorial hari ni. Kalau ada tak ada apa-apa nak tanya, saya nak dismiss kelas lah. Okay?
Okay, Mi.
Alright, so thank you everyone for today's class. Assalamualaikum.